So now we want to talk about turning points. The point that a polynomial changes directions from increasing to decreasing or vice versa is called a turning point. Think of a turning point as being the top of the hill or the bottom of the valley. The maximum number of turning points of a polynomial function is always one less than the minimum degree of the polynomial. So here's an example of a turning point. That would be a bottom of the valley. That would be a top of the hill. And this would be a bottom of the valley. So this leads us to the turning point theorem. A polynomial with degree n can have at most n minus 1 turning points. So if my polynomial is degree 5, I can have most 4 turning points. Now the actual graph may have 0 turning points, or it might have 1, or it might have 2, or it might have 3, or it might have 4. It's just that would be the maximum number of turning points they could have. If the graph of a polynomial has n minus 1 turning points, then the degree of the polynomial has to at least be n. So let's go back to our workbook. And let's take a look at number 6. And just remember turning points, the graph of polynomial function has at most n minus 1 in turning points. And they give you another definition here. And in mathematics, those top hills or bottom valleys, we refer to them as relative maxima and relative minimum. So that's just a kind of more formal mathematic name. But just think of a top of a hill or a bottom of a valley. So give the maximum turning points for the function f of x equals x cubed minus 21x plus 20. So here the degree of the polynomial is 3. So take 3 minus 1, that would give me 2. So that'd be the 2 turning points at most. In fact, they kind of gave us a graph. We can see it does have 2 points, one about here and one here. So now we want to put everything that we've talked about so far in this section together and be able to sketch a polynomial function. So we're going to first use the leading term of the polynomial to determine the end behavior of the graph. And then we're going to determine the y-intercept by evaluating f of 0. Determine the real zeros f and their multiplicity, so we'll basically go through set the function equals 0 and solve. We'll plot the x and y-intercepts and sketch the end behavior. And then we'll draw a sketch starting from the left end behavior, connect the x and y-intercepts in order that they appear from left to right. Remember, cross the x-axis if the 0 has odd multiplicity, touch, but do not cross if the 0 has even multiplicity. You can do some tests for symmetry. So when we do a test for symmetry, the function's even if it's symmetric with respect to the y-axis. So again, kind of a little visual picture here when it's even. Think of your absolute value function. I look at f of negative 2. That's the absolute value of negative 2 is 2. I look at f of positive 2. The absolute value of negative 2 is positive. Absolute value of positive 2 is 2. So this tells me that f of negative x equals f of positive x. So it's symmetric with respect to the y-axis. And then f is odd, symmetric to the origin if f of negative x equals negative f of x. An example of that would be like my cube function. F of negative 2 equals negative 2 cubed, which is negative 8. F of positive 2 equals 2 cubed, which is positive 8. So my y values are the opposite sign. So even function, the y value is the same, even though the x values have different signs. X values have different signs, but if it's an odd function, the y value is going to have the sign. And then plot more points if a greater level of accuracy is desired, in particular to estimate the location of turning points, find several between two consecutive x-intercepts. Alright, so let's see if we can put this all together. So here we want to sketch this graph. So first I want to figure out the end behavior. So again, if I were to pseudo multiply this out, this would give me an x squared plus a bunch of terms. FOIL that out, I get x squared plus a bunch of terms. X squared times x squared gives me x to the fourth plus a bunch of terms. So I just think about, hey, this is even. Power here is even. Coefficient of that leading term is positive. So my general shape at the ends or end behavior is going to look like this. That's kind of step one. Next, we want to determine the x and y intercepts. Well, the x-intercepts, let's do those first. And let's see, we have a factor of x minus 1, so my 0 would be 1, so 1 comma 0. X plus 3, that's going to give me a 0 of negative 3, so that'd be negative 3 comma 0 is my next intercept. X minus 4, set that equals 0 and solid, that gives me 4, positive 4. And now I look at my power. This is even, so this is going to touch. This would cross because my power is odd, and likewise it's going to cross here. Let's get my y-intercept. Well, plug in 0. So that's negative 1 squared times 3 times a negative 4. That would be 12. And so I'd be a negative 12, excuse me on that. So my y-intercept is 0 comma negative 12. And let's go ahead and let's kind of stop for a moment. Let's plot what we have. So I have an x-intercept at 1, negative 3, and positive 4. I know it's going to touch here, so it might go like that or go like that. It's going to cross here and cross here. I have a y-intercept at 0, negative 12, so maybe about here. My end behaviors, well, it's going to go up over here and go up over here. So I'm just kind of marking them in there. Probably want to do this part in pencil because once we actually sketch it out, we'll clean it up. Now, so I'm guessing it kind of goes through like this. It might go like that. It might come down here and kind of go through that. I'm not 100% sure. It's going to go, and it's going to touch here, come down, and something like that. I want to get some additional information. Now I want to get some additional points. So here's what we're going to do. We're going to go ahead and make a little table. And I'm going to pick some values. So maybe I'm going to pick here like negative 4. Let's do like negative 2. Maybe one here at 2 and 3. Just kind of get these points in here. And maybe I'll try 5, see if what we can get. Now, I don't want to plug these all in by hand, so we're going to make the calculator do our work for us. So let's turn on our calculator. I'm going to clear all this out. I'm going to do our table. I'm going to clear, and I'm going to enter this in. It's just being very careful. Remember to use your variable key right here next to the 4. Just hit it once to get your x. Subtract 1, parentheses squared, x plus 3, x minus 4. Now, I want to start this at negative 4. Oops. Did something wrong there. There we go. Nope. Try it one more time. There we go. I think I was hitting the subtraction key by mistake. So if it starts doing A and S, then you know, make sure you clear it and make sure you use the minus key or the negative key right next to the enter key. Step 1. Okay, so this is 200. Well, that verifies that. So negative 2, we got negative 54. Negative 1, we got, well, I guess we could include negative 1 if you want to. It'd be negative 40. So I'll go ahead and put that in. That might be helpful. 0 is negative 12. That makes sense. 1 is 0. Yep. 2 is negative 10. 3 is negative 24. 4 should be 0, and 5 is 128. Okay, so let's see what we got here. And I'm just reading them off. All right, well, at negative 4, this is way off the scale. So for my graph, this is kind of going crazy up here. Negative 2, negative 54, maybe about here. Yeah, maybe a little bit lower. So my graph's coming down here. Now it might be bottoming out, I'm not sure. Negative 1, we got a negative 40, so it's going to come back up here. It's going to go through these 2 points here. Now remember what we said, what it does at 1. It bounces. And then we go, 2 is negative 10, so it's going to come back down here. 3 is negative 24, so that's about here, so it's going to go through here. And then maybe it turns there. Maybe it turns back up, comes up through there. And 5, 128 is off the graph, so it's just going to go off like that. Now, last thing I want to check here is make sure this has the correct turning points. So my degree here was 4. That means I should have at most 3 turning points. Well, that'd be 4 minus 1 is 3 at most. And as I've got 1, 2, 3, so that matches. So that should be our sketch. All right, let's try number 8. So let's see what we got here. X times x is x squared. For that, that's x squared. Negative x squared times x squared is negative x to the 4th plus a bunch of terms. So I'm going to have a similar end behavior, except it's going to be even, but it's going to be pointing down. So my shape, I'm thinking going down this way and this way. That's my end behavior. All right, let's get the y-intercept. F of 0. Well, 0, negative, well, since that first part's going to be 0, it really doesn't matter what the rest of this is. We get 0. So my y-intercept is 0, 0. Let's get our x-intercepts. Okay, we got a factor of x. That gives me 0, 0. Power on the x is 1, so this is going to cross. Next intercept comes from x plus 1. That gives me negative 1. That's also going to cross. And x minus 3 squared, well, that gives me 0, 3, and that's going to touch. So let's plot what we have. 0, 0. Negative 1, 0. 3, 0. All right, so those are my x-intercepts. Then my y-intercept is also 0, 0. So, okay, that's not terribly helpful. I know this thing has to point down. So if we kind of mark it down here, my ends are going like this and like that. Something like that. And remember we said it's going to cross, cross, and then touch. So it should go like this. But I want to get some additional points. So let's go ahead and make a table. So let's do negative 2. I probably want to do a point in between here. So how about a negative 1/2? And we can do 1 and 2 and 4. Okay, so let's go ahead and quit out of this. And let's go back into our table. I want to clear this. And I'm going to type in negative x, parentheses, x plus 1, close parentheses, parentheses, x minus 3, and now I'm going to be squaring it. I want to start this at negative 2. Now I want to be sure that I hit that negative 1/2. So let's see if it'll let us do this. Let's try stepping by 0.5. So that's negative 50. Okay, that's a 0. So this is 3.0625. So a little more than 3. 0, 0 we got. 1, negative 8. 2 is negative 6. 3 is 0. 4 would be negative 20. Okay, so let's see what we got. So negative 2, negative 50 is off the graph. All right, so I know my graph goes down here and kind of keeps sinking. And way down here, it finally will hit that point. Negative 1/2, 3.6. That's just a hair above that, so might go like that. Come here. And it's supposed to cross here, so at 1, negative 8, which is about here, 2, negative 6. So maybe it's going to come down here, something like this, go through those 3 points. And 4, negative 20. Oops. I forgot it touches here, doesn't it? And goes something like that. And so we're just trying to get a sketch here. Last thing we want to do is check the turning points. Degrees 4, I should have at most 3 turning points. I got 1, 2, 3 turning points, so that is a match.